Alrighty, so we are finally moving on here to the next unit. Hopefully soon. So here's what dynamics is going to be all about. When you're getting ready for that test, and you're wondering what's going to be on the test, it'll be this. Later today, you will identify the 4 fundamental forces of nature. That's simple. It's kind of straightforward. I'm just going to give them to you. Straightforward kind of notes. Let me just zoom in a bit here. Okay. Then, and not in this order, you will perform an experiment to demonstrate Newton's second law. That'll be a lab that you'll have to hand in. You'll have to define the unit of force as the Newton. Now, here's where I got to pause for a second. Many of you on this last test will have me writing in the units for you. How many kids in the class? About 23. I had to handwrite units for almost 23 people. Okay, having said that, there's quite a few people that did their units right. Lots of you just ignore the units. Not allowed anymore, Tallahassee. You should listen to this part. Okay? Because it clearly says, in the course outline, provincial government says that you have to define the unit of force as Newton. My interpretation of that is, when you write a force, you must include the end. If you don't, then you haven't met that outcome. You must include the units. And I figure, well, if you have to do it for the end, then you got to do it for the other ones too. So if you don't know your units, it's time to learn them. Stop being lazy. I wrote them all in for you. Okay? So it says it right there. You will also define FNet. Ty, you do explain, you understand I'm teaching here, right? This is not a time to talk. It's time to listen. Cole needs to listen. He can't listen to you. He's got to listen to me.
Yeah, we're distracting every day.
We can solve that for you, Cole. You should define FNet as the vector sum of all forces acting on a body, and you will include the force of friction, the normal force, the gravitational force, and applied forces. And I'll teach you all this, obviously. You will construct free body diagrams, which are commonly known as FBDs, free body diagrams, to determine the net force for objects in various situations, including balanced and unbalanced forces and inclined planes. Inclined planes are fancy words for ramps. A ramp. You will solve problems, more word problems, involving Newton's second law, which is F net equals ma, and the kinematics equation. So in other words, all those word problems that we just did, we're going to take those and we're going to expand. We're going to keep building, kind of like the little Ukrainian nesting dolls. They get bigger and bigger and bigger. Same idea, right? So I expect you to be able to do all that stuff from the first unit and more. Depends on which way you look at it, doesn't it? It will include forces applied along a straight line and perpendicular forces. There are basically 3 types of problems that I'm going to teach you. There will be horizontal force with friction. You guys should listen. Okay, there's problem type 1. Horizontal forces. Horizontal means sideways, right? There will be ones like that, but this time the force is at an angle, like so. And there will be perpendicular forces both with and without friction. I call them top level or top down. You're looking sort of like bird's eye view from a drone, looking straight down. That kind of thing. And we're going to go back to our vector stuff, north and 30 degrees east of south and all that stuff. We just keep building. Okay, which is why if your binder's organized, you can always go back and find where that stuff is. If you need to, remember I have the what did I miss binder back there that can get your binder organized. Okay, so today we are simply going to do the fundamental forces, yeah. And if they don't put the fun in fundamental, then let's begin. How many fundamental forces are there?
4.
How'd you know? I think I said, right? The first force is gravity. Gravity's an attractive force. Good looking force.
Oh yeah, he's attractive.
Yeah. Don't let it get you down. I use that joke every year. Always gets a laugh. Sometimes more than others. Gravity is an attractive force. And it exists between all objects. All objects. I am an object. My paper towel dispenser is an object. I'm attracted to my paper towel dispenser. Fortunately, my paper towel dispenser is also attracted to me. Gravitationally speaking, of course. How come we're attracted to each other? Careful.
Gravity.
Gravity, but how come? Because we both have mass. Objects that have mass, in other words, everything, are attracted to everything else. So, I'm standing here, I'm attracted to the paper towel dispenser. I'm also attracted to filing cabinet. Good looking filing cabinet. It's a little square, but which one am I attracted to more?
That one. Filing cabinet.
Why?
Bigger.
Well, I heard two answers. One was because it's bigger, it's got more mass. You're right, Zane. And I heard someone else say,
Closer.
I'm closer to it. What if I stand over here, right in front of the paper towel dispenser? Now which one am I attracted more to? Tough to say, really, right? How come? Yeah, I'm closer to this one, but that one's still, depending on how much stuff is in there, probably way more massive, right? Excellent. Is it always attractive? Is it always like pulling me in? Or does it ever push away? Gravity only? Only pulls. The gravitational force between the center of the Earth and objects near it cause objects to fall toward the surface of the Earth. Allow me to demonstrate. Here's a roll of tape. It's near the Earth. Pretty exciting stuff. Okay? I said I couldn't make this fun, but I lied. That was pretty fun. The gravitational force between the center of the Earth and objects near it cause objects to fall toward the surface of the Earth. Things are attracted to Earth. Earth has a lot of mass. It's pretty darn attractive. There's what the Earth's gravitational field looks like. This is the whole unit, by the way. The next unit is all about gravitational fields, so we're going to get into that more. Basically, you just need to know that gravity is a fundamental force. Now, what do I mean by fundamental? I never really defined that.
It's always there.
What is, well?
It's fun. And it's mental.
Neither of those two things are correct.
Gravity is force.
What makes something fundamental?
Wow. It has to be there. Very basic.
Very basic. That's good. What if something is not fundamental? Then it's complicated, complex. In this sense, in the scientific sense, fundamental means that it's not made up of anything else. Like gravity just exists; it's just there, right? Whereas other forces are built on or are because of gravity. Okay, so they're because of or they're made up of gravity. Does that kind of make sense? That's what fundamental means. It means that all other forces are because of them.
You got a gnarly little coffee ring on your paper right there.
Yeah? Thanks.
Gnarly?
Take that as a comment. No. The second fundamental force is the electromagnetic force. Electromagnetic force, not near as attractive. It holds matter together by providing a force that binds atoms into molecules. Can I do this? I want to cover stuff up. It's not letting me. Well, maybe here. Excellent. The electromagnetic force is the force that holds matter together. It's literally what's holding you together. Oh. Otherwise, you'd just be, well, a bunch of molecules floating around. It provides the force that binds atoms into molecules. So, the hydrogen atoms that are in your body are combined with the oxygen atoms in your body to create what? Water. Water molecules that make up like something like 90% of your body. Right? So it's what's holding those atoms together to make water. And you probably know from grade 9 science The force between particles of opposite charge is attractive. In other words, what? Opposites attract. Positive charge, negative charge, they're attracted to each other, right? Is it similar to gravity? No. Sorry. In fact, scientists don't really have a true understanding of what causes gravity. It's probably one of the most fundamental things. Everyone knows about gravity, but no one really knows why. There's theories.
Well, what's the why for this?
Electromagnetic force?
Why though?
Why? I would imagine it has to do with electrons that want to transfer and make things balanced, kind of thing, right? Nobody really knows. It's pretty complex, John. Yeah. So electromagnetic force is the force that holds particles of opposite charge that's attractive, right? Now remember, you know this as well. I know you do. The force between particles of the same charge is repulsive. Ooh, yeah. Repulsive. What does that mean? Well, it means that positives and positives don't like being together. Negatives and negatives also don't like being together. This is all, again, the electromagnetic force. Now, if you stop and you think about things, how many atoms in your body are positive?
Half.
How do you know half?
Yes, because we're held together.
Okay. How many atoms in your body are positive? Well, the correct answer is lots. Right? Numerically, I don't have an answer, but lots, depending on how big you are, I guess, right? So all of these positives should be doing what?
Well, no, because they're mixed in with the negatives.
Oh, okay, okay. So what about, like, in, say, who had some cereal this morning for breakfast? Anyone? Okay. Right? Most cereal is fortified with iron. Iron is way down here, number 26 on the periodic table, which means it has 26 what in its nucleus? Protons. All of those protons should be doing what? But they don't. Right? You don't see the iron molecules busting out of your cereal bowl in the morning. How come? Well, I'll tell you why. Since like charges repel one another, how can positively charged protons exist closely packed in an atomic nucleus? No? Did I not say like 10 minutes ago? What did I say? I said, don't write everything down. This is more just to remind me of what to say. I already said it before I saw it, so I don't even need to, right? But you might want, if you're reading this back over, you might want it. Keep in mind, all of these notes are posted to Schoology. You can print them out.
And they're optional.
Is that the third part?
This is the third one.
Oh, okay.
This is the third one.
Hey, wait.
Yo!
Okay? So the third fundamental force is what's called the strong nuclear force. Strong because it's really strong. Nuclear because it's?
Nuclear.
What does that mean?
And the nucleus.
In the nucleus. In the nucleus. So, the strong nuclear force is the force that holds protons and neutrons together in atomic nuclei. It is the strongest force, the strongest fundamental force. But the thing is, it only acts over very, very, very short distances inside an atomic nucleus. Extremely short distances. It's the strongest, but it only works really close quarters. That's a good point. We'll come up to that right away. That's after the fourth one. So all that picture really is showing is what? Showing positive protons, 1, 2, 3, 4, negative electrons, Hey, what element is that? Is that something you should be able to figure out? Yeah, what element is that? I'm getting my mouse like it's going to point up there. Number 4, beryllium. Be, beryllium. Okay, so just to summarize, what do we got so far? We got gravity, the electromagnetic strong nuclear force. The last one, it's called the weak nuclear force. It's a little weaker. It's called the weak nuclear force. It is responsible for some kinds of radioactive decay, such as the decay that creates radon gas. And I'll explain why that's important to us right away. Who cares about radon gas? Anyone? River, do you care about radon gas? You probably should. Brett, do you care about radon gas?
I don't know what it is, but I care deeply.
Well, radon gas is the number 2 cause of lung cancer in Canada.
Yo.
It is particularly prevalent in Manitoba, and Dauphin in Manitoba is one of the worst places for radon gas. Yeah, hate to tell you. However, it only seems to affect people that are smokers. I shouldn't say that. It's more likely to cause lung cancer
I'm all good.
people who are smokers.
I'm all
Okay? But radon gas is not good. Something about the soil in Manitoba that causes radon gas to be created. And the way it gets into your house, the way it gets into your house is it gets through the cracks in your foundation. Okay? It comes up through your basement. Many of you, if you're going to live in a newer home, might have a radon gas sort of dispersal system. You can put them into older homes. You have to dig a hole like a sump pit, and you put in a device that basically vents. Instead of the radon coming up through your basement, sort of diverts it, sucks it, and sort of shoots it out the side of your house. And as it goes into the atmosphere, it sort of decays and it becomes immaterial.
Why is it more?
So,
Why is it bad here?
why is it bad here? I don't know for sure, but it has something to do with the soil content in Manitoba, and Dauphin in particular has a lot of it.
So is radon gas, is it like in cigarettes? Radon.
That I don't know.
It's like literally on
I think it's just that because smokers are more likely to have lung cancer, and radon gas can cause lung cancer, it's kind of like,
just accelerates.
it's just accelerating, yeah, they're kind of combining together, right? Yeah.
Really causes smoking, or it causes radon gas?
You can buy a radon detector. I have one in my house. I got lots in my basement. Pardon me? It just means the concentration is really high, right? It's just long-term exposure to it can cause lung cancer. Get outside every once in a while. Don't spend your life in the basement. Yeah. Okay. I'm almost done. Hang on. Stay with me here. The weak nuclear force is the next to weakest force. It is not the weakest. It is the second weakest. And it acts only when particles are close together. So strong nuclear, weak nuclear are only really in play in really, really short distances. Leo.
Are you gonna ask us like, oh, what is the second weakest?
Bingo.
Are you?
Yep.
Great.
You are supposed to be able to identify the 4 of them, right? So you will see a question like, which of the following is not a fundamental force? Or identify what are the 4 fundamental forces, or something like that. All you have to do is know the names, really, right? I'm going to take that a little stretch further, and I'm going to ask you to know the order of their strength. So we're going to figure that out. You should know the order of their strength. Okay, so let's just draw a little picture here. Should you write this down? Yeah, this looks, yeah. So I'm going to write strongest over here, and I'm going to write weakest over here. Which one's the strongest? Strong nuclear force. It's the strongest one. Right? Now, I haven't told you which is the weakest, but I did tell you which one was the second weakest. So that's this one right here, right? So I'm going to put it right there. Weak nuclear force. Which two are left? Gravity and electromagnetic. So Ty said something interesting about 5 minutes ago, kind of along these lines. Which one is stronger, gravity or electromagnetic?
Electromagnetic.
Okay, I got about half and half there. Which one is stronger? How many people say electromagnetic is stronger? Hands up, said the sheriff. How many people say gravity is stronger?
Gravity.
Okay, well, how can we logically think this through? Okay, so Brett's saying, I'm going to hold my pencil up, Brett, and you explain with me holding a pencil up why you think electromagnetic is stronger.
Because the pencil still stays intact.
Yeah, exactly. If gravity was stronger, it would be pulling the bottom away, wouldn't it? Right? Gravity's really right.
Right on.
So, which was the weakest?
Gravity. Really?
Gravity.
Oh. Okay, so what about if you were like on a place that had like really high gravity?
Okay.
Oh!
Okay.
That's pretty good. That's great.
No, that's a good question. So, what Dave is saying is,
I said one. I said
no, I don't think it was a bird.
no. Nothing that's burning. She's so red.
I think it's a good question.
Like, cause it's got
If you're on a, what he's saying is, if you're on like a gravitational or a black hole, perhaps.
Yeah.
Okay. So, excellent question. If you're in a black hole, will that pull molecules apart?
There has to be a point where gravity becomes more than electromagnetic.
I would think so, but on the other hand, okay, so let's think about it this way. If I've got two atoms that are together,
What about an acid? There's an acid.
acid.
Yeah.
Okay, so let's say I've got my two atoms, let's say it's hydrogen gas, H2, right? H2 is one of the diatomic atoms. So I got my two of them, same as a black hole. Both of the atoms are attracted to him, right? Not just the front one, but the back one too, right? So would it pull apart? I don't think so. What it would do is it would just pull them both, right? So I'm thinking, right? I don't think it would pull things apart. The only way it would be is if some force, some mystery force could sort of hang on to this one, but not this one, right? But then again, it would only have to be another black hole, right? Right? That'd be the only thing that would be strong enough to do that. I'm going to say still electromagnetic.
What if you like threw a pencil in a black hole? Wouldn't it like pull the lead out of the lid?
No, it would actually just be like stretched down to infinitesimally small.
Hey, we don't know yet.
Yeah.
Do we know that yet?
Say that again, Robert? No, I can hear you.
Like stretched out, right? 'Cause,
Yeah.
like the gravity is stronger the closer you get in.
Yeah.
So it would just be stretched.
Okay, so you're saying that because one end of the pencil would be closer than the other, so that tip end you want would be pulled and stretched out?
I think so. Yeah.
Maybe.
I think it would be.
Maybe.
What about if you're holding it?
I think we should see if there's a head talk on black holes.
Yeah.
Yeah.
I think that sounds like an excellent idea.